Sorry, I've been talking a lot the last couple days. This is actually a superset of yesterday's training. I'm going to show some more things here, but also there's a presentation that I do. There's about 50 slides. It's the end of the day, so I'm not going to get too crazy with those, but we'll just hit some of the more fun ones. Yeah, so there were a few people here at the training yesterday. Is that what I'm getting? So I'm actually going to cover, I've done more with the Zeppelin notebooks than I had with the Spark notebooks. Not until Andy Petrella got in town did I actually really start to pay attention to that thing. So yeah, he's been helping me with it. Let me see if I can zoom in. All right. Clear out some stuff here. So just to start, if you guys want to check this out, if you just like Google flux capacitor, that's the key name for this, Spark and Docker, yeah, you'll be able to find all this stuff. Basically, we sort of forked this for the by the bay stuff, but and then we like simplified by the bay so we can keep it controlled and focus on just Cassandra, Spark Notebook, Kafka, and Spark. So flux capacitor actually has a whole ton of shit here. Let me show you. This is a fun little diagram. So yeah, this is the general, if you kind of follow in the magenta there, this is what we did yesterday. We like had a script that simulated users adding ratings to Kafka. And we have Spark streaming that's listening and pulling those messages, parsing it, storing it in Cassandra. I don't think we got to any of the MLlib stuff, so I'll talk a little bit about that. There's a little the data scientist guy down at the bottom. Yeah, he's using like Zeppelin or IPython or Hive directly, Spark SQL, and then goes up and around. So I'm using like Elasticsearch to actually store the recommendations. I don't really have any good reason for it. I could have used anything, but they had a nice REST API, and I was trying to test out the Elasticsearch Spark connector, and yeah, wanted to write some code. So yeah, like actually turns out well. Yeah, like we'll go through this whole thing with an end-to-end demo. So I think probably everyone's here that's going to be here. So why don't we start with a live demo? If you guys, and this is going to be interactive too, so if you guys can navigate to sparkafterdark.com on your phones or laptops. All right, like you guys with me here? Please participate, otherwise this is going to be lame. And just pick your top three, or like actresses or top three actors. Just poke on them. So, boop. Got to get Tiffany Amber Thiessen in there. I love her. Some Marlon Brando. There's no rhyme or reason why you would like these people. There's no. This is a totally politically correct, so that's why I'm having guys choose guys, girls choose girls, it doesn't matter. We're in San Francisco. So all of these are being, as you're doing that, I'm using the Kafka REST API, and it's actually submitting directly back to, like through this pipeline. So let me see here. I'm actually going to pull up a notebook where we're going to analyze these likes as they're happening. So let me run through. Yeah, have you guys selected? Yeah, everyone's got their votes in. What we're going to do here is take these likes and then run PageRank on it, and then we're going to run like ALS matrix factorization, pretty basic stuff out of Spark. And yeah, we're actually going to generate real live personalized recommendations for you guys. So don't click those 3 links on the bottom, because that's the surprise. So there's, yeah, these 3 down here. So after we're done going through the analysis, which would normally be like a batch job or something, then we'll actually, okay. So I think, let me see how many people. Okay, so yeah, we got about 300 likes so far. I can run it again and get the latest. Yeah, have you guys all seen Zeppelin before? It's pretty cool. You could do SQL, you could do Hive, you could plug in your own, you could do Flink. Yeah, obviously Spark is the default. This is where you would define all the connectors, like you just give it the Maven coordinates, so I'm using the Cassandra connector, obviously. And then, yeah, like Elasticsearch and Spark Streaming. So here I'm just loading in some of the reference data. Yeah, each of these actors, actresses has their own ID, and I just scrape some stuff off of like IMDb. Got some JSON. Got their images, pulled them in, put them. Oh yeah, so this is all running within one Docker instance, by the way. So it's actually running out on EC2. This is it right here. Yeah, this entire pipeline is the whole flux capacitor or the by the bay training. So let me see. I'm at the like Cassandra command line here. So we'll do use pipeline. That's the name of the key space from lakes. So I'm going to just do count. All right, so we got 364. So let me run this one more time. It's pretty quick. And then we'll take it to the next steps where we actually generate and populate those links at the bottom of the Spark After Dark page. I put a little help button on here. It's kind of fun. You can send me questions if you want. Yes, I won't answer them, but it's hooked up to like Zendesk and some chat thing that makes me look like I'm online and responsive. So if we do a little analysis here, we can actually kind of start to see some of the counts, some of the more popular people, Morgan Freeman. Yeah, do you guys want me to go through the code, or y'all pretty good with data frames? Trying to figure out how like detailed to go. Because I could either talk about code or I could talk about my presentation, or yeah, so let's just keep going here. I'll circle back on some of this. Let's go to the next notebook. This is generating. So there's basically two types of like recommendations, right? There's personalized, non-personalized, or yeah, two types that we'll talk about here. So the basic ones, if I just run this notebook while I'm talking, would be just show me who is the most liked from this group, right? So yeah, obviously totals are skewed over time, that kind of thing. But if we get those counts, so we've got the count here, and then we can run PageRank. So picture if you're the person on the left and you liked 3 or 6 people or whatever, that's that's the overall like graph. So here we can drive like the most desirable users, like the LinkedIn top influencers. So that ran here, that we got the top ones, and then we'll actually, so yeah, this wrote out to Elasticsearch, and then we're gonna do the last one here, which is personalized. So now this is the matrix factorization. So let's run this. So yeah, quick note on matrix factorization. You basically take a snapshot of what your like user to item, like matrix here. Right now we're just using like, so it's zeros and ones. And then you want to factor out, basically create two matrices that when multiplied together will match as closely as possible to the values that are there right now. And then that lets you fill in the blank ones, right? So when like user number 5 logs in, we just like scan across and find the most probable person. Like top 10 recommendations or whatever. Okay, so let's go back to here. And we should be able to click. So this is top users, so this is just the overall count. So I showed this graph earlier, that was Morgan Freeman was at the top. That was that bar graph. If we do top influencers, this is PageRank. And personalized are ones straight out of ALS. Did you guys all get results for those that actually did this? Right, do you feel good about your recommendations? Are they accurate? I have 5 dudes, that are my recommendations. I'm not quite sure how that happened, but okay. Yeah, so again, we did like that whole thing right now. We have Ganglia hooked up in here. We've got Logstash, so The problem with these notebooks is that you don't really get a lot of feedback when like errors happen. So the cool thing is I've got all this wired up to Logstash and then Kibana on top. So this is refreshing every, I think, 5 seconds and showing us any errors. It's got Zeppelin in here as well. That's part of my filter, so you see some of the WebSocket stuff opening and closing. But yeah, this is actually how I was debugging, right? Like during development, because you don't see sometimes, especially with streaming, like you don't really see any of the streaming errors. So the streaming errors, if you're hooked in, if you've got like Logstash pushing the Spark logs into Kibana, then you're good. Okay. Then one last DevOpsy thing. Yeah, these are kind of fun. You can see I've got Ganglia set up here. So it's pushing system metrics from so yeah, this is the actual Spark cluster itself. This isn't like this is the overall system right here, but then we could see file system usage, thread pools. For the Spark jobs, we can see some of the file I/O, block manager. Yeah, this is important block manager stuff. Keep an eye on these. Keep an eye on your GC. Keep an eye on the heap. Yeah, so there's a lot of good metrics. It's really kind of an ugly interface, but okay. So I think that covers basically what we did yesterday. So that'll get you caught up. And now I'm gonna, oh yeah, I was gonna show one more. So this is Spark Notebook. This was actually from the training yesterday. This is what we used. And if I'm lucky, I might be able to get this working. Yeah, if like Andy's here, he can help me. There's this cool thing that we did where we actually were able to, from a line chart here, we could actually watch the streaming ratings come in as they were coming in. We could see a line, like a moving average every, I think it was 10 seconds. So it would actually populate this. I wasn't having much luck with it before, but let me try it. So it's gonna start, kill that. This is the Spark UI here, so you can see Zeppelin actually is a long-running job. So just like Spark Streaming, when you start Spark Streaming, which I just killed down here, yeah, that's a long-running job. This is when I connect to Zeppelin, or through Zeppelin, it's creating this long-running job running behind, and every cell that you execute actually creates a mini job, or a full job for Spark. And then any notebook that we connect, so I just connected this ratings thing. This shows up as a job as well. This is Tachyon. This is the UI for that. Didn't get a chance to get that fully wired up, but yeah, Tachyon's kind of like the distributed cluster, or like a RAM disk sort of thing. So it's been running for 5 hours here. That's when I started the Docker image earlier today. And then this, so yeah, before I forget about this, let's try it. Here we're setting up our SQL context. We've got this concept of a rating. I found this as part of Spark After Dark when I first created it. I was looking for some kind of dating data set, and I found one data set that was used for someone's PhD thesis, and I just asked, hey, can I use it? I'm not making money off this. He said, yeah, it's fine. So it's 17 million ratings, and it's for, I think, about 100,000 people. It's super easy. If you search like dating, data set, collaborative filtering, yeah, you'll find it. But it's basically from user to user, and then their rating. So for the actual demo that we just did, that was likes. That was just basically 0 and 1. But this is 1 through 10. So that was the actual dating, or yeah, the data set that we used yesterday for the training. And then, yeah, we had scripts that would send it in. So I'm going to try to do that. Let me get yeah, this was Andy that actually wrote these. Andy Petrella, the creator of Spark Notebook. So here we're actually going to start a Spark streaming job inside the notebook, which is completely crazy, but we actually saw this quite a bit at Databricks. People really wanted to do this, which we couldn't understand because why would you want to do it from a notebook if you shut down the notebook? But in reality, if you do shut down the notebook, like your local notebook, it's still running in the background. The problem is you don't really have a lot of monitoring on it. So what we saw customers do is actually schedule a new job, because you can schedule jobs with these notebooks. So for example, this is Databricks Cloud here. You can actually specify a notebook here. So it would be the streaming notebook that would take the data and then train the model or whatever it would do. And so they actually scheduled this. There's a little scheduler here. And they just did it every minute. So each minute they would check if the job was up, if the streaming job was up. If not, they would just start it up again. So yeah, they didn't lose data because they were using Kafka, but they would be possibly 1 minute out of date. All right, so I think we got that. And now we're going to start the job, the Spark streaming job. And then in theory, I'm going to start the script inside the Docker image. It's going to populate this chart right here. Let's keep our fingers crossed. Ooh, 412. All right. Let me tail this log and make sure. Oh, yeah, we already have data. All right. So, wow. So yeah, this is just a, this is an actual data set, which I was looking for because I wanted some sort of, statistically normal type of data, not just randomly generated. So yeah, this is the moving average every 10 seconds, or a sliding window every 10 seconds. So you can see we're sort of converging on 6, which I think for the overall data set, I think that was about the mean for all of that. So what's interesting is that, so this is Andy's notebook. He forked it from iScala notebook and then basically tore it apart and built in all these widgets. I think there's D3 underneath the covers or whatever those fancy libraries on top of D3. But yeah, Databricks Cloud doesn't even really have this. They have a lot of cool visualizations, and but yeah, not much streaming. So I was blown away because basically what I had been doing, and this was the case with Zeppelin also, is you just basically hit refresh on the cell. You just keep rerunning the job to show. Let me get back to that first. Scrolling within Zeppelin is really weird. These cells grab hold of the focus. But yeah, I would have to rerun this every time and watch it change, and it was kind of silly. But so yeah, he's using WebSockets beneath the covers on that one. All right. So more on the dating stuff. Let me pull up the slides. I think I'm just going to blaze through these because it's already 5:30. But yeah, Spark After Dark. There's me at the Playboy Mansion, Netflix with my mom. That's Databricks at the booth. And then, yeah, I have to put the plug in for IBM because they're actually letting me be here today and not work. Or I guess this is my work. But yeah, we're hiring. We're only hiring nice people. That was the one thing I asked when I joined. I said, are there all nice people? He said no. Yeah, my boss said no, we have 400,000 people. They're not all nice. But moving forward, we can find nice people. So yeah, I'm the culture person, I guess, when it comes to interviews. Yeah, just started this, the advanced Spark meetup. I don't think Databricks likes it, but because they haven't signed up or anything. Yeah, none of those guys have. But yeah, I'm actually going to work with some of the engineers. I know those guys really well, so they're going to come over. The next one is September 3rd. we already had two, right, like pretty good turnout. Some of the demos didn't work out, the normal stuff, but this next one, basically the whole point here is deep dive into the code, right? So yeah, like you can read about it. It's not going to be the high level, here we are with Verizon and all that stuff. This is the code. These were the design choices made. Yeah, I was there for a lot of these. And I mean, yeah, they're all like public JIRAs too, right? So they don't always post the private like design docs, but they do post enough to understand what's going on. And then of course the code is the final answer. So yeah, why Spark After Dark? This series called Playboy After Dark was kind of cool. I wasn't around in the 60s, but when I worked there, I stumbled upon these in like the archive room and popped the tape in and saw like Jerry Garcia, Marvin Gaye, yeah, very progressive things for the time. So I was into that. Yeah, the whole point here is to generate the high quality recommendations, which we just did, and then also demonstrate Spark Streaming, GraphX, some of the more popular libraries, some of the integrations, Cassandra, Elasticsearch. Popular dating sites, my favorite is Farmers Only. I'm not sure if you guys have heard of that. It says city folk just don't get it. Yeah, they've had commercials for like 2 years, and I finally looked it up, and it's a real site. I think I'm on about 6 of these. All right, so Spark, you guys have seen this. Spark in production. Yeah, this was kind of interesting. So, right, like Databricks just did this poll recently, and they were asking, right, like, how do you want to deploy Spark? Do you want us, Databricks, to manage it for you within Amazon? And that's the middle one there. That's 30, or that second one says 30%. And then 70% people said, no, yeah, we want to do it ourselves. So that's what kind of prompted me to start using Docker. Plus, I just wanted to kind of play around with it too. It's been pretty successful. We probably had about 250 people do the training over the last month, and there's always the random problems if you give them like the USB, because we were sure about giving them USBs, and so you didn't have to connect to the internet. Some guys like USB ports just didn't work on his Mac. We had no idea what was going. That was the worst. Yeah, we had EC2 as a backup. So the full talk, I'd be talking about all this, but I think we're just going to hit some highlights here. So I showed you this. Yeah, so these are the themes. These will also, as part of the Spark meetup, we'll be like digging in deeper to these. So yeah, sign up for it. Come on out. Yeah, bring your coworkers. Offered to speak if you want. If you want to help out, like diving through code to help prepare, that'd be great too. Yeah, this is kind of funny. Back in the 80s, the first time I really started thinking about parallelism. So yeah, this is Peter Brady. He planned a date for, he planned 2 dates on a Friday night. I wasn't sure what to do. So I guess fortunately that week, there was a foreign exchange student or something that like moved in that day that looked just like him. So yeah, like how convenient was that? So Arthur is on the right, and he basically, he like multiplied himself. So yeah, he was able to accomplish his task, and I think there was some weird thing at the end where the girl that Arthur went on a date with actually liked Peter, and it's all wacky ending to these 1980s, 70s shows. So yeah, non-parallel, you'd have to add these all up. ON, that's not good, versus login, pretty basic. Spark is parallel, and so are the Olsen twins, apparently. All right, so Daytona gray sort, this was kind of the highlight of Spark's, like recent. So the big thing here that they were trying to prove is that Spark isn't just in memory. So probably the most important thing here is the smallest thing on here, which says it's on disk only. They like disabled all the caching. So all the caching that everyone's been talking about, the guy from like Sigmoid and all those people talking about filling up RAM. So they turned all that off. And this is purely on disk, and the point was to compare it to MapReduce. So the old record, the whole point of this, so Gray is Jim Gray, right? Famous computer scientist, former computer scientist. And then you are given 100 terabytes of data. You have to sort it as fast as possible, and you can use whatever you want. So the old record was Hadoop at Yahoo. They were a little fuzzy on their hardware. It was bare metal though. But yeah, they had 2,100 nodes, and they had a throughput. Those bottom two are what you should kind of pay attention to, especially that second to last one. The sort rate for the overall cluster is 1.42 terabytes. Spark comes along, does it 3 times the throughput with only 200 nodes and a third of the time. And this is all on disk. So this is more, this sort of speaks to the execution optimizations and pipelining and those synchronization barriers that Mike Olson was talking about. Yeah, so how do they do it? This was kind of the first round of performance optimizations. This was about when I joined. So I was able to hear a lot of the design discussions around here. Oh yeah, I also saw the bill because this was Amazon. Going the wrong way. Yeah, those 200 nodes were, I think they were i8 some things, but yeah, they were pretty beefy boxes. They were 200. So actually, that's what the IBM Spark Tech Center is going to be doing. I think in the next couple weeks, actually, we've just provisioned a bunch of soft layer. That was part of the agreement, the partnership with us and Databricks, to do a lot of performance testing around it and basically do these kind of tests, but on a daily basis, on a per commit basis, right? You have to make sure individual commit level, not at the end when everyone's piling in commits. Okay. Oh yeah, that third box is, since they already have the nodes, they decided to try 1 petabyte, right, 1,000 terabytes, and see if it scales. So it's the exact same throughput, the 4.27. So the details, actually, I think this is the next meetup that I'm having on September 3rd. There's 3 key JIRAs that cover these optimizations specifically for this Daytona sort thingy. So they paid attention, of course, to the shuffle phase, which is obviously the most intensive, the biggest bottleneck here with these big data processing frameworks. So there was a lot of low-level things. The big one being they switched to NetE. So yeah, not a lot of people at Databricks like Java. They're all Scala heads, but yeah, they actually buckled down and sucked it up and implemented the low-level NetE. So a lot of byte buffer reuse, smooth out the GC profile. And then of course ePoll to keep everything in system space, kernel space, and not have to bounce up to user and create buffers when you're going from the network card to disk and that kind of thing. So this is the next round, Project Tungsten. The first parts of this were in 1.4, and then I think the final parts are hitting now. 1.5, which I think is in review. The big thing here is this bytes to bytes map, which is an enhanced hash map. So the key is better CPU locality, right? So you're not, or cache locality, so you're not ping-ponging, clearing out the CPU cache and then reloading it. So if you picture, there's kind of a handwritten, this is actually from a Databricks whiteboard here, but if you're trying to do large scans or large aggregations, if you point to your key values like that versus pairing it up like that, and then picture going down, you're constantly clear, because that first one points to, it's basically, right, you can do tricks where you're 8-bit aligning and that kind of stuff, right? So you could do that better with the cache aware. So picture all these keys right next to each other, right? And if you're skipping over it, key value, you have to jump over the value, jump over the value. If you're just looking for keys, then you can just scan the keys without having to dereference that first pointer and then skip over the value, which could be, not 8-bit aligned. Okay, and then, there's also more, there's going to be a lot more JVM bytecode generation going on. There's a couple, so that's the cryo. I think someone mentioned it earlier today. So that's the recommended, it's a serialization technique, and I can't remember who actually built it, maybe Google or something, but Cryo, that's the recommended. So this is a serialization framework when you're going either across network, if you want to serialize in memory. So now with some more bytecode generation, like techniques going on beneath the covers, we can actually like bypass Cryo and do it even faster because we actually know the domain, right? So we know these objects versus Cryo, which is trying to do its best with like a general technique. Let's see, Catalyst Optimizer. This will be another topic for the meetup. The big takeaway here is use data frames, not RDDs. If you're writing to RDDs, you're old school, which is kind of cool, I guess. If you like bytecode and assembly and that kind of thing, you could definitely impress your girlfriend or boyfriend. The key here too is if you're writing Python, if you're writing two RDDs in Python, there's tons and tons of extra overhead because you're really pickling things back and forth between Python and the JVM. So if you write to the data frames, it's going to actually generate bytecode for you from Python. I think columnar stuff you guys probably already know. Parquet was mentioned a couple times. Big thing here is storing columns next to each other, right? You can do a lot of compression, you can do run length encoding, all these other things from your recent interviews. Also to column filters, partition pruning, like row filters, predicate pushdowns. So these are all part of the data sources API, which like a lot of these. So the Parquet implementation, there's CSV, there's Avro, there's a recent ORC, just came out I think with Spark 1.4. And these write to a common Spark SQL data sources API, which basically lets you do pushdowns and all that kind of stuff, right? So you write to this API and then you can partake in this Catalyst optimizations. Yeah, these things here. So this is the actual, Catalyst is a replacement for the Hive optimizer, the Hive query optimizer. The way that it was written, it doesn't take advantage of the the Spark job execution and task optimizations and that kind of stuff. So they started to strangle that code base out, and this is the new optimizer. So any new data source, like I'm working on DynamoDB right now, that one's starting to pick up a lot of steam, and I just have to adapt. If they give me some predicate, I have to push that down into DynamoDB so I'm not returning more data. Like the Cassandra connector does it, the Elasticsearch connector does it. So DynamoDB will too. Spark streaming, this is a classic Spark streaming deployment. You have, if you picture a normal Spark cluster with 5 nodes, so there's master and then 4 workers, you would take one out and dedicate it to the receiver. That was, if you guys were here a couple talks ago, someone asked about Kafka and why they switched off Spark streaming and Kafka and replaced it with something. Someone asked a question about the direct Kafka streaming. So there's this new Kafka RDD where it's not this dedicated single node receiver anymore. So it actually treats the Kafka stream just like it would treat a disk, where it has offsets within the stream, right? So every block or each partition that gets created in your Spark cluster knows the start and the end, and it can rebuild from that. So there's no more write-ahead log specifically for this Kafka implementation, which was a huge bottleneck. If you're writing out to HDFS every time that, for each batch of data that comes in every 500 milliseconds second, if you're writing to HDFS, that's going to kill you just for the write-ahead log. So basically this assumes success, right? So if there's failure, then it has to go back and rebuild. It's not always writing, assuming everything is going to fail. So we just did that. I think I'll skip the approximations. It's worth noting, yeah, there's this library called Twitter Algebra that's pretty cool. There's full examples within Spark Streaming. Yeah, these like approximation techniques are very useful in a streaming scenario where data's coming in fast and you don't want to use a traditional hash map, for example, to maintain counts. So you just want to estimate it if it's good enough. Yeah, so there's examples in the Spark Streaming code base that uses like Twitter, this, yeah, like this Countman sketch algorithm. And then of course, hyperloglog. Redis just picked this up, I think, a year or two ago as a first-class citizen. You can, with like 1.5K, yeah, like you can represent 10 to the 9th elements. That's pretty incredible. And at like about 2% error. So this is actually in the Spark code base. It's on the RDD, and it's count approx distinct by key. So it's all been built in for you. Yeah, something interesting, which I didn't realize until I first ran this Spark Pi example. This is actually in the Spark code base. So they have this like example that is like estimating pi, and I couldn't figure out why they chose this as a valid example, like what's the like benefit here, but basically if you picture this technique, and it's a form of a Monte Carlo simulation, which was used back for the atomic bomb from the old Manhattan Project. What you do is you know basically picture throwing darts, just kind of picking. If you take a square, so like you obviously know the diameter, and if you can sort of backtrack there, so if you throw, and then take the number of red dots divided by the total dots, that's approximately, yeah, and then multiply it by 4, that's approximately pi. So if you, yeah, so we can actually run this, and you can have it do multiple iterations. And I think at 10 iterations, it was getting like 3.10, and then if I did 100, it was 3.1415, you know, 4 or something like that. So you can see as you do more iterations and throw more dots, you actually get closer. So it's a nice parallelization problem. Okay. Talked about non-personalized, personalized. So basically, I have 10 forms of like recommendations. So these are the 2 non-personalized. Talk about similarity. Yeah, so whenever you're trying to make generations, you have to compare everything to everything, right? That's the classic all-pair similarity problem. So there's like techniques that you can use to reduce the amount of shuffle, because the naive shuffle is just huge. You know, picture M is 500,000, N is 500,000. We actually had this problem at Databricks, and yeah, multiple times at Databricks, people came to us. So you have to minimize the shuffle, right? So either you reduce the rows or you can reduce the columns. So yeah, dim sum, yeah, which has a pretty funny name. This came out of Twitter and a guy from Stanford, and I'm sure a few others, but yeah, I know like those 2 guys. So what they were trying to do is figure out ad similarity to figure out which ads to show you on the Twitter app. And when they put this particular algorithm into place, they actually had 40% efficiency gain over just straight cosine similarity, which is where you're, you know, using cosine to figure out, basically like measuring the angle between 2 points. So that's a way to reduce M. Yeah, how much time? And then let's see, we got, yeah, this is like another cool one. So yeah, this is the best book ever written, by the way. Yeah, this mining massive data sets. So there's a form of this actually on like GitHub. It's also part of Spark packages, which is that kind of second tier. If you're not actually committing into the code base, you can like submit your stuff to the Spark packages, and it's kind of a 1.5 class citizen, not a full Spark commit, but yeah, the whole point here is to pre-process your data and like bucket it into smaller number of buckets and that pre-process step right? Like uses some sort of similarity to figure out which ones would be similar and then bucket those together. And then what you can do there is then compare in parallel, right? So if you have 50 buckets, you would spin up 50 tasks that would do the comparison. And it's called locality sensitive hashing. Sparse matrices, pretty basic. Oh, yeah, this was cool. When I was at Netflix, I actually didn't realize this. Right about when I got there, they were, well, actually, no, about 5 years before I got there, they were spending quite a bit of time moving away from explicit ratings, which 5% of the user base actually did. They moved more towards this sort of user behavior, which is like commonly called the implicit feedback. So searches, clicks, hovers, where on the search results you actually clicked, like how far down did you scroll, how long did you watch the movie. So we did collaborative filtering. Here's some tech stuff. The Nitro guys probably can school me on this, but yeah, so this is actually from my profile, back to the dating thing. Trying to figure out similar profiles. So again, you have to compare my profile to all the other, right, like Tinder users or OkCupid users, whatever. Farmers only. Wait, what's that?
How many messages did you get because you have 3 new properties?
Oh, yeah. Actually, I did go on a date with a girl that had 2. Yep. She was crazy. She was nuts. Okay. But yeah, she had clean teeth. And then let's see. Yeah, this is kind of interesting too. So people that I've liked, yeah, that's another signal. So take their profile and then run another comparison against everyone else. Maybe surface some people that way. Here, I just threw just a common pipeline thing. This is right off the Spark ML page. But yeah, like a common pipeline, you would get the raw profile, you would tokenize it, split it up into n-grams, right? Like whatever you have to do, build feature vectors, run your models, and then generate predictions. Right, like get what you would like clear out any stop words, any simple words, things that aren't high value. Okay, 1 minute. This was another one. So I actually got this email about, I don't know, maybe 6 months ago now. I keep saying it was last week, but it's actually like 6 months now. And this got flagged and like risen to the top, and I couldn't figure out why. And I realized that my profile actually, she actually commented on things like, yeah, I have sonic hair. Yeah, she mentioned toothbrush. I'm from, yeah, I wear my Cubs hat a lot. She mentioned Midwest. So yeah, California, like West Coast. So it's sort of like an indication that this is a high value email. So yeah, check it out. Right, like versus the thousands of other emails that I get a day, which is not true. Yeah, and then, so there was this really good blog post where this guy reverse engineered Tinder, or basically wrote like, yeah, so he wrote an app to simulate his actions on Tinder and, figured out the protocol or whatever he did, right? And he actually has some code to do this. It's not Spark code, it's not MLlib code. I haven't gotten around to porting it, but where people that you've liked, if you, sort of average out their faces, right? That's the term, right? Like eigenface. And I think typically what I've read is about 150, 160 pictures, that's good enough. And then any future people that come along, right? Like this app would actually run it against this average and see if it was within some tolerance. And yes, if so, it would flag me and say, hey, yeah, this is someone that physically you might like, based on the 27 points or whatever it is for facial recognition. Yeah, I just have 2 more. Yeah, so this same guy wrote this conversation bot where he sort of softballs out generic, right, like trite opening lines, and he's not controlling this. He's just spraying out to everyone. And if their responses are positive based on sentiment, he'll try to respond again automatically. If it makes it down to the 3rd one, then it'll notify him this is someone that is actually sort of interested in you. So But yeah, and so I spent a lot of time thinking about what I would say for these trite opening lines, like, hey, what are you doing this weekend, right? But it'll be like Sunday night or something, you know? So that's a bit of intelligence. And then this is number 9 here. So this is, yeah, maintaining the spark. This is after you've found your special someone. How do you stick it out? Yeah, there's another cool demo I've seen. Actually, I think this was GraphLab guys that built this. They haven't open sourced it yet, I think, because they're using IMDb, so they're probably a little nervous about it. But if you're a couple, it's a Friday night, put your kids to bed, whatever, you're trying to figure out what to watch on, probably like Netflix. You put in your personal preference. At that moment, they put in theirs, and it'll generate this pathway. So it's right, like combination graph problem plus right, like item to item similarity. So based on plot, right, yeah, based on actors, that kind of thing. So yeah, typically it's about 5 or 6 in between, but I didn't have room for that or the energy to go to actually do the research. But somehow Waterworld ended up as the top one. Final recommendation: get off the computer and actually meet people. Yeah. And then we're hiring. And check out, that's supposed to be me, but I found out later that I think it's a girl. So, but because of the hair, I picked it. And she's wearing pink too, I guess, so, yeah. I think Holden, yeah, maybe suggested that to me. Yeah, my old coworker. Yeah, so that's it. Yeah, do you guys have energy for questions? Yeah, you too. Oh. Yeah, so the question is, how do I make sure logging is happening on the workers themselves that are handling it? Yeah, each worker has to have that log stash agent that's installed and then configured with whatever directories that Spark is writing to. Yeah, but like, did you say Yarn also? Yeah, because Yarn kind of has its own thing going on there with the logging, right? Yeah. And then, yes, if you're in Yarn, make sure that you're using -jas supervise, right, so that thing will restart. And then, yeah, whatever, because, yeah, once the driver dies, your Spark streaming is hosed, which is why you should always use like a reliable source like Kafka, Kinesis, that can actually store data. The one problem with Kinesis is it's 24 hours is the max that you get, not unless you're Netflix and you can, right, kind of sway them to do more, but yep. Cool.
Thanks, Chris. All right, thanks, guys. So it's